In this video, we'll talk about tangent planes and their equations. So suppose that we have a surface S, this blue surface in the figure, and then we have a point P on the surface which has coordinates x0, y0, and z0. And then we bring two traces, C1 and C2, that pass through that point P. And the tangent lines that are parallel to those traces, T1 and T2, form what we call a tangent plane. So these two lines that pass through this point P form a tangent plane. So this tangent plane, this beige tangent plane that we have on the figure. And the equation of such a plane is given by z minus z0 is equal to the partial derivative of f with respect to x evaluated at x0, y0 times x minus x0, and then plus the partial derivative of f with respect to y evaluated at x0, y0 times y minus y0. And this is given that the partial f of x and the partial fx and fy are continuous. Let's now see how we can find the equation of a tangent plane to a given surface at a specified point. So suppose that we have the surface z equals to x squared plus x times y plus 3y squared, and we want to find the tangent plane that passes through the point 1, 1, 5. So here, the x0, y0, and z0 are the coordinates 1, 1, and 5, respectively. So in this case, first of all, we need to find, first of all, we have that the z would be equal to f of x comma y, and this would be equal to x squared plus x times y plus 3y squared. And we want to now find the partial derivative of f with respect to x at x comma y, which would be just the derivative of x squared, which is 2x, and then derivative plus the derivative of x times y, which is just y, and then derivative of 3y squared is equal to 0 with respect to x. Now, if we evaluate that partial derivative of f with respect to x at 1, 1, at the x0, y0 that we have here, then we'll find that this is equal to 2 times 1 plus 1, and so that is equal to 3. And we have the partial derivative of f with respect to y at x comma y, which would be partial derivative of x squared with respect to y would be 0, and then partial derivative of x times y with respect to y would be just x. And then we have the partial derivative of 3y squared with respect to y, which would give us plus 3 times 2y. So that will be x plus 6y. So we have f of y evaluated, fy evaluated at 1, 1 would be equal to 1 plus 6 times 1. So that is equal to 7. So we can now go and write the equation of a tangent plane. So we'll have a z minus z0 is equal to fx x0 y0 times x minus x0, and then plus fy x0 y0 times y minus y0. And we can now plug x0 or y0 are both equal to 1, and z0 is equal to 5 from here. So x0 is equal to 1, y0 is equal to 1, and z0 is equal to 5. So if we plug those in, we have z minus 5 would be equal to fx at x0, y0 is equal to fx at 1, 1, which we found is equal to 3. And then we have x minus x0, which is 1. And then we have plus fy at 1, 1, which is equal to 7. And then we have y minus 1. So that will give us z minus 5 is equal to 3x minus 3, and then plus 7y minus 7. So we'll have that z is equal to 3x plus 7y minus 10, and then plus 5 from the other side. So that will give us that z is equal to 3x plus 7y and then minus 5. So this is the equation of the tangent plane. So the z is equal to 3x plus 7y minus 5 is the equation of the tangent plane.